Hey, good morning, everybody. Thanks for joining us today for our Wi-Fi 6 presentation. We're going to jump right into the content. I wanted to start by introducing our guest speaker, Terry Henry. Terry Henry is a consulting system engineer at Ruckus Networks, now part of CommScope. Terry's been a long-term friend of mine, a colleague of ours. He's been in the IT industry since 1995, so quite a while. He's been with networking companies like Brocade and now Ruckus since 2001, so over 20 years of experience working on enterprise networks, working on Wi-Fi since its infancy, since its beginning. So Terry has a really unique perspective on seeing this Wi-Fi develop over time as these standards matured. So today our focus primarily is talking about Wi-Fi 6, the new technological elements in Wi-Fi 6, and how it's going to help administrators with things like density challenges, throughput challenges, and so on. Terry shared a slide deck with me, and I'm really excited about the content that he's going to present. So with that, Terry, I'll turn it over to you.
All right, great. Thanks, Don. Hope I can live up to that introduction. Okay, so Wi-Fi 6 or 802.11ax. So prior to, up until now, we've gone through 802.11bgn, 802.11ac, and 802.11ac Wave 2. And it's all been about speed. It's been about throughput and speed under ideal conditions. And so this was to bring on the first 10 billion devices, right? Since 1999, or really 1997 up until 2015-ish, it's been about getting those first devices on the network. But now, with Wi-Fi 6 or 802.11ax, the next generation, it's about efficient use of the air. So it's not necessarily about speed, it's about using the air, that shared spectrum, more efficiently, which leads to more speed and more users. So really that's what it's about. It's about efficiency in this next generation. And we'll talk about all the pieces that make it more efficient and ultimately faster for the users. So up until now, things have been alphabet soup, right? So we had, 802.11b, 802.11a, and then we went to 802.11g, we went to 11n, and then 11ac and AC Wave 2, and this is 802.11ax. However, the Wi-Fi Alliance has decided to number everything in generations now. So the new generation is called Wi-Fi 6, which is 802.11ax, and so they back numbered the other one. So AC became Wi-Fi 5, N became Wi-Fi 4, and so they've really done this for the consumer, right? So they don't have to memorize or think to themselves, is N faster than AC or AX, or which one's the latest generation? They can go by generation numbers. So in theory, the next generation should be Wi-Fi 7, followed by Wi-Fi 8, unless they, take a page from the playbook of Apple and Microsoft and skip a few. But for the most part, these should just follow generation numbers. So it's primarily for the consumer. So what's the promise? What is Wi-Fi 6 supposed to bring us as users? So there's several things, and if you look at this list, it will seem unrealistic. You'll be like, there is no way one generation of Wi-Fi can actually give us this many improvements, but it really is, and we'll talk about how. So outdoor reliability, more reliable outdoors, higher speeds overall, improved coverage, up to 4 times increase in capacity, support for new applications, reduced power consumption on your end devices, like your phones and IoT devices, things like that, and more active clients per AP. So this seems like an unrealistic list of all these things that can be improved with one generation of Wi-Fi, but it truly is. So this is, I know it's a bit of an eye chart. However, we can quickly see how far we've come. So from 1997, when the first version of 802.11 wireless came out, which was 2 megabits of peak PHY rate. So 2 megabits was a very best case scenario then, to our current 802.11ax, which is a peak PHY rate of 9.6 gigabits per second. So in about 20 years, we've gone nearly 5,000 times increase in speed. And through many different innovations over that time, but you can see how far this has come. So this is where I'm going to spend most of my time, is on the 6 building blocks, or the 6 individual advantages that 802.11ax brings us. So the first one, and probably the most important, is something called OFDMA. So in previous generations of Wi-Fi, it was kind of a free-for-all, right? Because the air is a shared spectrum, and so if you want to talk as a Wi-Fi device in the air, you have to listen, make sure no one else is speaking at the same time as you, and then you try to talk. And if someone happens to start talking at the same time as you back off for a random period of time, you start to talk again. Hopefully nobody else talks at the same time as you. If they do, you back off and start over again. So it's like if you put, 50 people on a Zoom call or a WebEx call, and it was an open discussion group, it's difficult that there wouldn't be people overlapping, right? And so what 802.11ax or Wi-Fi 6 brings us is it brings order to that chaos. So it's like previous generations were like a kindergarten class with no teacher, right? It was just chaos, right? People trying to talk and screaming, and what Wi-Fi 6 brings us is we bring in the teacher, and the teacher controls who can talk and when they can talk and how much they can say. And that's what OFDMA is. So it is the access point becomes the teacher and controls who can talk and when they can. So it's perfectly efficient use of the air. And so your cell phone on LTE actually does that today. So if your cell phone has something to send, it goes to your cell tower, asks for a time slice. The cell tower will give them back that slice and say, here's when you can talk and what you can say, or how much you can say. And so it's all about efficiency. So it's not an increase in speed per se, but it's efficient use of each cycle in the wireless. Next is multi-user MIMO. So if you're thinking to yourself, we had multi-user MIMO before, we absolutely did. However, we had a 4x4 was really the fastest you could go. So there was 4 send and receive antennas simultaneously. However, multi-user MIMO on 802.11ac was unidirectional. It was only downlink only for multi-user MIMO. For uplink, it was single user MIMO. So in 802.11ax, not only do we now get 8x8, so we get 8 spatial streams, so double the number of spatial streams, but we also get uplink and downlink multi-user MIMO. So essentially, more devices talking simultaneously in the same airwave. This one, which might be the most important for us as users, is power efficiency. So there's a technology called target wake time. And so in previous generations of Wi-Fi, if you were a cell phone or you were an IoT device, you had to keep your Wi-Fi radio on all the time in case someone had to talk to you or you needed to talk. Your radio was on all the time, consuming battery power. However, with target wake time, you pre-negotiate with the access point when you're going to turn your radios on to check if anyone has anything to say to you. So, for example, if I'm a water leak detector, when do I have to talk on the network? Well, never, unless there's a water leak, right? And so you can pre-negotiate with your access point that when you're going to wake up and see if anyone has anything for you. So the standard allows for up to 5 years. So really, you could keep your radios off for 5 years, wake up 5 years from now, see if there's anyone needs to talk to you, and then go back to sleep. Now, I don't think anyone's actually going to implement 5 years. That's a crazy number. But maybe you wake up once a day or once a month to see if there's an update and send a status. Otherwise, you can keep your radios off. But I'll show you some testing results in a minute, but you can actually get some real meaningful gains on even on your cell phone. We've seen 10% or better gain on cell phone battery life. Next is QAM. So I'm not going to try to explain the details of QAM to you, but this is throughput. So this is up until now how we got faster for the most part from generation to generation. So if you think about radio waves for Wi-Fi, in a 5 gigahertz signal, you have 5 billion waves per second. And so what QAM is the amount of data you can send per radio wave. So in a previous generation, we had 256 QAM. We now have 1024 QAM, which doesn't translate into, I used to be able to send 256 bits, and now I can send 1024 bits. It's combinations of bits, but ultimately, it's a 25% increase in overall speed. So up until now, I've been talking about capacity and increased efficiency. This is a 25% increase in speed. So it comes with both of those pieces. Long OFDM symbol. So this is outdoor reliability. So it does increase, throughput for outdoor signal. And I'll just leave that. And then lastly, BSS coloring. So this is an important innovation, especially in high density environments. So if you can imagine that you're in an apartment building and you've got neighbors all around you, so you can see 20 different access points from different neighbors where you're standing. Today, up until 802.11ax, you'd have to wait until everyone on your channel was quiet before you could speak. So you have to wait for everybody. And with BSS coloring, though, it colors your network, or it adds an identifier to your network, which basically says if somebody talking belongs to my immediate network, then I have to wait and back off appropriately. But if they don't, if they're one of my neighbors and they're not part of my network, or they're not part of my color, then I can just talk over top of them. So basically, instead of having to wait for 20 access points to be quiet, and all of their clients, maybe you're only waiting for 1 or 2 or a couple of access points. So a much smaller number and much more capacity and enhanced Wi-Fi coexistence with neighboring devices.
Hey, Terry, let me ask you this. Appreciate the explanation on these building blocks. And I know this may be a tough question, but when you look at all these enhancements and developments, are there any couple that you feel stand out as the real game changers? I mean, to me, I think the upload download on MU-MIO has a lot of ramifications for IoT and video and things like that. So I think that one, but I'm also seeing, all the things related to density, which right now in an era of kind of social and physical distancing and people pseudo self-quarantining still, it's hard to imagine a packed arena, but we're not going to be like this forever. So obviously we'll get back to that. What do you feel, when you look at this in a historical perspective, maybe projecting in the future, what do you think is going to be the real game changers? Is it the higher density, or is it, as you mentioned, the throughput? What do you think?
Well, I think it's all those, but I think, the power efficiency is a big one. I talked about battery savings. So where we've, for IoT, we started to go with things like BLE and Zigbee as alternate protocols because they were much more power efficient. And we've moved away from Wi-Fi for IoT, but I think you're going to see all of that come back. And with the density, so in the past, maybe you got 20 users or 50 users on an access point, and that pretty much maxed it out. Or, in the case of our high-end ones, maybe 100 or so. But when you get IoT in the mix and you get, temperature sensors and door sensors and lights, and you get potentially hundreds of devices on an access point, you need to be really efficient with your airtime. And that's what this brings us. So OFDMA brings us efficient airtime. And so you can have all of these devices, simultaneously on the network. So it's not so much about throughput, it's about efficient use of that air, and that's what really brings home in Wi-Fi 6. So it's what we've been missing up till now.
And one other question, and this is more of I know we're not talking about products at this point. We're talking about this new technology without a product pitch. My question though is this: is everything that's going to be Wi-Fi 6 certified has to have all these things? Is there really any differentiation between brands, do you think, at that point? I mean, if I've got a Ruckus AP from CommScope that's Wi-Fi 6, and I've got the knockoff Joe Blow brand from China that's Wi-Fi 6, does that mean they're really the same, or do you think individual manufacturers will be able to go beyond these capabilities to have their own specific take on these issues and make their secret sauce better?
Right. So there is a baseline. So everything has to be tested through the Wi-Fi Alliance, and so just out of interest, the benchmark in the Wi-Fi Alliance happens to be Ruckus access points that everything gets tested against. However, so everything has to meet the benchmark to be certified Wi-Fi 6. However, what that benchmark is depends on the device. So it doesn't have to be 8x8 multi-user MIMO. It could be a 2x2 or 4x4. So there's a lot of variances within that certification process, but there's also some real advantages that individual vendors can put on this, and that may mean what controller and controller type they're using and how the access points interact with each other, or it could be antenna technology. So there's other pieces that you can pack on top of Wi-Fi 6, but everyone should meet the basic criteria in order to be certified.
So all Wi-Fi 6 will have some of the same capabilities, but they're not all created equal, and your mileage may vary depending on what brand you get. I got you.
Absolutely, and as you walk down the aisle in Walmart, you'll see all kinds of claims on access points that are 400 times faster, and a lot of that is just not realistic numbers, right? I mean, just like the 9.6 gigabit per second maximum PHY rate, that's impossible in the real world, right? So even though that'll be the big claim on the box, that's not a real world scenario. However, you have to truly do your homework to find out who benefits.
Yeah, good point. Well, thanks for that explanation.
Sure. And leading up to that, let's talk about performance. And so what's advertised is a 4 times performance gain for AX over AC, and AC is quite fast. I mean, for most users, AC is fast enough, right? So, and again, it's not all about speed, but so if you look at the advertising, you look at the marketing folks, the expected gain is 4 times is what they say. So the long symbol gives you 1.2 times, 1024 QAM gives you, 25% more, or 1.25 times. 8x8 multi-user MIMO gives you double the 4x4 we had before. OFDM gives you, 33% increase. So if you add all those together, the theoretical gain is 4 times, at least according to the marketing folks. So the reality, however, is you need a lot of tuning, and this is kind of a best case scenario, right? So, so in the real world, you would expect somewhere around 2 to 3 times. So if you can get double the speed of 802.11ac Wave 2, I would say that is a very, very substantial gain.
That's incredible. Yeah, I think it'll be 2-3 times faster in the real world. I think that's an incredible gain.
Absolutely, for sure. And if you can use that airtime more efficiently, and you can, use things like BSS coloring to ignore your neighbor's networks and just worry about your network, I think you'll get some substantial gains that the user will actually appreciate. So really, where we used to, wire all the desks, right? Everybody had a wire at their desk, providing network access. Now, for the most part, your Wi-Fi is faster than wired. So, I have a Galaxy S20 Ultra, and I can do about 1.5 gigs of throughput on my phone. So that's pretty amazing. Now that's a high-end AP and in a pretty clean environment, but I certainly can't get that on a wired network. So one other thing about OFDMA and the benefit is we have a lot of short packets on our networks, right? Especially things like voice over Wi-Fi. So very small packets, but lots of them. So in previous generations of the Wi-Fi, each packet you had to send from each client had to go in a separate packet. So you sent a packet or a frame with a preamble and your data, and then it had to get acknowledged. And then the next user can send theirs and it gets acknowledged, etc. So not very efficient use, especially for very small packets. And very small packets are hard on access points. So often, if you see a bake-off between two different vendors on access points, they don't use 64-byte packets. They use big packets. They use 10, 24-byte packets because they're easier on their CPUs and much more efficient. And so what OFDMA gives us is it allows us to take a response to many clients and put them in the same packet. So we can send one preamble and packet out and to multiple clients simultaneously, and then we can ACK multiple packets simultaneously with the same packet. So this slide is supposed to be representing an amount of time, right? So in the lower box, we're done in a third of the time of the above one, if that makes sense. So according to this, in a dense environment, you get about 70% of Wi-Fi traffic is small frames, and that's absolutely true. So all kinds of management frames, acknowledgement frames, IoT, updates, voice over Wi-Fi calling, all of that is small traffic. And so it's in previous generations, that was very, very hard on the CPUs of the access points and not efficient use of the spectrum. So the other thing is, and something that we will see in real life, we as users, is, and the target wake time extends battery life. So in our testing, this was done with a Google Pixel. We got two different phones. We got 10% increase on one and 12% increase on the other, but it's about a 60-minute or 1 hour increase in time, right? So assuming an 8-hour battery life on the phone, when it was constantly sending data, that is, we saw a 1 hour increase, which is very, very substantial. So if you can get 10 to 12% increase, that is pretty amazing just by changing to the latest Wi-Fi generation, and that'll get better over time, I would imagine.
Yeah, for me, I mean, just in my own life, I've realized that I used to have a battery that lasted all day, and it wasn't an issue, but I had to add one of those, the new charger where you can just lay your phone on it and it charges without plugging it in. I had to add one of those on my desktop, and now when I'm at my desk, I have to throw it on there because otherwise I might be, 7 o'clock at night and I've got no juice, which it isn't a crisis, but I'm on the cell phone a lot. I use it for audio a lot. That's my main use of it, and email, of course, but just that'll kill it now. So it's nice to have these power improvements, especially in the enterprise where people are using their mobile for everything. I mean, really for everything. So that'll be a nice benefit.
Right, and it's rare to see somebody that has a desk phone now. Almost everybody uses their cell phone for calls, and Wi-Fi calling is certainly more reliable indoor. So unless you have a multi-$100,000 DAS system in your office, you're probably using your phone and using Wi-Fi calling. And so anywhere where we can increase that battery life is a great benefit. And certainly you don't want to be sitting at your phone with a wire hanging out of your phone, charging it while you're trying to get work done. So this is my only pro Ruckus slide. So everything up until now has been just generic part of the standard, right? So the Ruckus difference is, up until now, we have a technology called BeamFlex. And so BeamFlex is there's over 100 patents on our antennas. And so you put us side by side against any other vendor, and we will absolutely blow them away for coverage and density on an access point. And basically the reason is because rather than sending a 360-degree omnidirectional signal around our access point, we kind of aim the signal. So we have, thousands of different antenna patterns, and we beam that signal towards the client. And as the client moves, we switch which antenna pattern we use to follow the client. So so we get a more pointed signal towards that user, if you will. Polarizational diversity allows you to follow the client. So if you lay your phone down or pick it up, the antennas on your phone don't move, or well, they do move, I should say, with the device. And so we can follow those antennas and keep your signal consistent. And lastly, channel fly is the ability to do channel changes based on the noise in the environment. And we can take a statistical analysis and find the cleanest channels and move your APs to the cleanest channels. So that's what makes Ruckus different than other vendors out there. So you add all the benefits to Wi-Fi 6 on top of that, plus some new benefits. So BeamFlex is now uplink and downlink. There's some enhanced channel selection. So we've made a lot of improvements that are specific to Ruckus, which gives us a real advantage over other vendors. So
let me ask you a question about this one, because we've seen in the real world some massive differences in the past, prior to Wi-Fi 6 with BeamFlex in a replacement scenario. Like we did a warehouse that was using barcode scanners for inventory management, and they had a different solution, a non-Ruckus solution, and they had 25-ish APs in the warehouse alone. And we used one of our tools, this Echo scanner, to go in and do a design. And when just Wi-Fi 5, not even 6, we were able to put in a Ruckus solution with a dozen, like half as many APs and superior coverage because of BeamFlex. Are you saying that, is it possible that with Wi-Fi 6, that radio count would stay the same, or do you think that it's possible to get even efficiencies there where you may not need as many radios for an application like that?
Well, yeah, so in theory, with Wi-Fi 6, you should actually get a marginal increase. So you should get about 3 dB better in Wi-Fi 6 versus Wi-Fi 5. But for the most part, going to Wi-Fi 6, you're going to keep the same number of access points, unless it's a very dense environment. However, there is a lot more. All the benefits of Wi-Fi 6, plus we've made some efficiencies. So, your network will be faster and certainly more users per access point. So, in the past, even on our very high-end access points, the theoretical maximum was about 500 users on an access point. Right. Our high-end access point now, the theoretical maximum is 2,000 users per access point. So. Wow. So in a very high density environment, yeah, you may very well get away with far fewer access points.
Wow. Let me ask you this last question about this. I mean, I've heard a lot about BeamFlex, and this seems to be a point of confusion with a lot of folks I've talked to, and they're trying to conflate or compare or say they're the same to say BeamFlex and beamforming. I know beamforming is an older tech in a Wi-Fi standard. Can you just briefly talk about the difference between, the benefit of BeamFlex and beamforming? And isn't BeamFlex, is that a Ruckus only technology?
Right. So BeamFlex is a Ruckus only technology. As I said, there's 100 patents in our antennas, and BeamFlex is all about the antennas. So it's all about us being able to focus a signal. We switch which antenna and which antenna pattern we use to focus that signal towards the user. So, as opposed to, if you think of a regular access point as a light bulb, the light is very dense at the bulb, but it fades out quickly. BeamFlex is more like a flashlight that we're aiming towards the client. And so the difference with BeamFlex is it is only from the access point side. So the client doesn't know anything about BeamFlex. They don't have to have a specific client or a specific driver to make that work. Beamforming, on the other hand, is part of the standard, and it does somewhat focus the energy, but certainly not to the same degree. And
Mm,
both the client and the access point have to support beamforming. So it's certainly not even remotely close to as efficient as
mhm,
BeamFlex, and it has to be a bidirectional situation in order to have
mm.
any improvement whatsoever.
It sounds like the beamforming may have been intentionally confusing. Like, I mean, it almost seems like they named it that to intentionally make it sound like it's BeamFlex without actually being BeamFlex. I don't know the history behind that, but that's what it seems like to me.
You're right. It's a hint of BeamFlex, I guess. You know.
All right. Thanks, Terry.
But anyway, yes, other vendors do try to say that it's equal, and it's certainly not. You know, BeamFlex is a real physics hardware advantage on the antennas that other vendors don't have. So, but you know, we will go up against anybody head to head and blow them away. So, my intention was to do a real live demo. However, due to bandwidth issues in my neighborhood, I'm going to show you some screenshots instead. So sadly, I couldn't do a live demo. Normally, that's how I would do it. But at the end, I will show you how you can sign up for your own 60-day trial, and we'll send you an access point, and so you can try this and do your own demo if you wish. So really, this is our cloud dashboard, and another difference between us and other vendors is we have Ruckus Cloud, so you can add your access points to our cloud. But if you're cloud adverse, or you know that's just not your favorite, we can go controller list. So one of the access points becomes a controller for 128 APs. You can use a hardware appliance controller. You can use a controller that runs on a VM, and you can. It's the same access point. So if you want to move from one controller type to another, if you start on cloud and you decide this isn't for me, or your auditor decides that isn't for you, then you can easily just reset those APs back to a different controller type. So, you know, other vendors, if you want to go from cloud to something else, you're probably throwing all your access points away and starting over again from scratch. However, so this is our cloud dashboard, and very, very simple, right? So you've got Google integrated maps to show you your locations, your venues. We have one venue here, which is your location, so your offices or campus, whatever the case, your networking devices, so your access points and switches, how many clients you have on your Wi-Fi and switches, but very clean, you know, online environment. But really, to get your network up and running, anybody can get a network up and running in 5 minutes, right? So there's really 3 steps, and they're highlighted here in this purple box. So add your venue or use the built-in one, add your networking devices, so your access points, and then add your Wi-Fi network. So real quick, we'll go through that, and I'll show you how easy it is. So add a new location, right? As I said, Google Maps integrated. So you give it a name. So I call this Florida office. My other one's called New York office, I think. You add the address in here, and then, you know, optionally you can import a floor plan and position the APs on the floor plan if you wish. But for right now, we're just going to give it a name and put in the address, and then click create. We have a venue, easy as that. So as I said, Google Maps integrated. Here's my original one. Here's the new one I just created, which is Fort Lauderdale in this case. It's grayed out because there's no access points that are in that venue. The other one is green because there's you know, no alarms. The access points are working correctly. So as soon as I add APs in there, it'll turn green. Obviously, if there was an issue, it would turn red. So that's our new venue. So someone says, hey, we're setting up a new office. 30 seconds later, you have a new office running. Next, we add APs. So a couple of ways to do this. One is, so manually, we choose the venue. Where is that AP? Is it in the New York office or is it in the Florida office? Give it a name, add its serial number, and click create, right? So easy as that. And then wherever that AP gets plugged into the internet, the first thing our APs and switches do is they go out to our registrar and say, hey, is anybody looking for me? And based on the serial number of that device, the registrar will say, oh yeah, we've been looking for you, and it will then download the correct version of code and its configuration, and it will be up and running as easy as that. The other way to do this, of course, is there's a phone mobile app, and from the mobile app, you can either add the serial number, or you can just use your camera, scan the barcode off of the AP or off of the shipping box, and then your AP is added and ready to roll. So, in theory, your shipper receiver out on your loading dock, or your receptionist or office manager could just, take a picture of those serial numbers as they come in, and your APs are ready to go. So then, the next day or the next week or a year later, when you get around to installing them, they are, waiting for you, ready to roll without any user intervention. So easy as that to add an access point, really a couple of clicks. So we now have 2 access points added. So one of them is grayed out because it's not online yet. But as soon as I plug it into the internet, it will be online. And then lastly, your step 3 is you need to add your Wi-Fi network. So Wi-Fi network, you give it a name. So for a new SSID, and then you choose your type. So is it pre-shared key, which is probably what we see in 90% of the cases, right, where you type in a passphrase. You can do 802.11ax enterprise. You can do cloud path, which is our certificate onboarding engine. You can do a captive portal, which is, you go into a coffee shop or a hotel and it pops up that logon box. Or is it just open with no authentication, which is never recommended, but it's there. So in this case, we'll go pre-shared key. Over on the right side here, we type in our passphrase. We choose, is it WPA2? We now support WPA3 and mixed mode WPA2 and WPA3. So, because the client has to support it, and the vast majority of clients are not WPA3 capable at this point, we can run a mixed mode and authenticate them with either way, depending on what they're capable of. So it'll choose the higher level. But in this case, we're just going to go WPA2, add a passphrase, click next, you're done. Then choose the venue. So where do you want to deploy that new network? Is it in both of my locations? Is it just in one? Is it on all the APs or a subset? Is it on both radios, 2.4 and 5 gigahertz, or only one of those? And you can schedule it. So maybe I only want that network live from 8 a.m. to 6 p.m. and I want my network shut down overnight. You can do that all from here. But basically, you just activate it and then click create, and you're done. So your new network is built. So really 3 steps, take you maybe 60 seconds to get, your location, get your access point added, get your network up and running, ready to roll. Then, just for fun, we'll create a guest network. So we create a captive portal. So easy as this. So back, same thing. So we give it a network name. We call it guest net. So that's what it will show up as the SSID. We choose captive portal as the type. For options, you can have a click through, which is just, it shows terms and conditions and the user just okays that, or a self sign in, so you can let your users create their own sign in, which is what we're going to do next. You can do a host approval. So the user fills out a form and then it goes to a host inside your company for them to approve and say, okay, this user's good, we'll validate them. Guest passes, you can pre-build guest passes and have receptionists hand out guest passes as people walk in the door for a period of time, or third-party captive portal. So we'll choose self sign-in, and then we can do things like Facebook logon, Google logon, Twitter logon, LinkedIn, or SMS token. So an SMS token is the user in the logon box will put their cell number in, and we will text them a code to get on the network for a limited period of time. So, and then optionally, we can collect email addresses of users who connect to the network. We can set a time frame. So is that password good for, 12 hours, 24 hours, a week, a month, 6 months? You can choose when you want that to expire, but it's as easy as that. Click those boxes, and then next it. Then we can customize the portal any way you want. So language, change the logos, change the welcome text, add a marketing message, terms and conditions, or just leave it. So this right pane here shows what it's going to look like when you're done. So as you change those parameters, it's going to change in that pane. And then we next it, again, choose our venue and create it, and you're done. So easy as that. You now have your PSK network up and running. You have your guest network up and running with, Google and Facebook and LinkedIn and Twitter authentication, all in the matter of a couple of minutes. And one of the recent things we've added, so we've always had some really good reporting inside of Cloud, but we've now added a big data analytics engine. So what this analytics engine does is it's constantly pulling statistics off of your cloud instance. So, all the statistics on what kind of applications the users are using, what connection events they're seeing, and so it's pulling all this in a big data analytics engine in the back end. And so we can give you some amazing reporting and analytics on what's happening with your network. And more importantly, as a big data analytics engine, we can see all of the other users, although you as a user can't see other users, but we have access to all of our clients. So if a new version of iOS comes out, for example, and we see users across multiple customers having the same issue, then the big data analytics engine can report that and say, hey, we've seen an issue with, this version of iOS, and here's how you fix it. So that's the beauty of analytics, is it will give you a root cause analysis, and it will also give you, information on how to fix that problem. So this is the incident detection dashboard. So again, built into the cloud. So in this case, it's showing P1, P2, P3, P4 incidences. So priority 1, 2, 3, 4. So priority 3 and 4 mostly, just informational. Priority 1 and 2s are what you got to look at. So this is kind of a graphic view of your network, the whole network, and then drill down into different controllers and different zones and networks, etc. And they're going to be, red if there's a P1, or orange P2, well, dark orange P2, light orange P3, etc. And you can drill down. You can also drill down by category, so connection performance, infrastructure, and time frame. So, you want to see what happened just over the last day, or over the last, 7 days, over the last hour, etc. This is probably the best part of analytics, though. You can drill down to an individual client. So client calls you, says, hey, I can't get on the network, or I'm having issues, and of course, clients are always really helpful, right? They're like, hey, the network's broken. What's wrong with it? Well, it's broken. It's down. Can you tell me what part of it? Yeah, all of it. It's all down. So, you can actually find that user, find their historical data, and drill down to exactly what's happened to that user over a period of time. So you can search for that user, not just by MAC address or by IP address, but by the name of the device, by the username, by the iOS, by the OS type. So you want to look at all your iPhones, for example. So you can find that user in a really free form input box, and then we can see, from this client's perspective, their total connection time, good connections, average and poor, which probably means they're too far away from the access point. Connection events, you can see all the events that's happened to this user when they've roamed from access point to access point, their connection quality. So you can see, at some points, their connection quality has gone to poor. So are they too far away from the access point? Are they out in the parking lot smoking a cigarette, trying to, do their work, right?
This is to me a huge game changer, because I don't know how many of us have had a situation where we've gotten a call or email from someone that said that, hey, I got a problem with my Wi-Fi. It was a couple of days ago or yesterday, and they sometimes wait. Hey, it was before lunch. My question is, on this connection quality graph and this data, how far back can you go? I mean, I see on this selection window, you've got it set for just looks like about a 24-hour period. Can it go back farther?
Oh yeah, for sure. We can go back weeks. Absolutely.
Weeks. Okay.
Yeah. So yeah, lots of ability there. You can go back to, and you can see exactly, what the issue is. So in the history here, we can see, you know, what the failure was. So it's an EAP failure. Here's a DHCP failure. So the DHCP timed out. So, you know,
Yeah.
did other users have a DHCP issue at the same time? You know, so yeah, you can go way back, and you can see, are they roaming? Did they move from access point to access point when the problem happened? So you can get some really detailed information on a per client basis, and across multiple clients. So you can run a report across, you know, a single AP or a network or a WLAN or a client, and get some really detailed information about that user. As well as, you know, what protocols they're using, what applications they're using. So some wonderful data. Right. So just more of the same. So here's a network analytics, but, you know, you can see, you can set SLAs on things. So you can set an SLA on connection success or connection time, or, you know, a multitude of things, and you can set an SLA. So you can say, hey, I want all my users to connect in 2 seconds or less, and then you can use the slider to choose that, and then it will give you a percentage of how many are meeting or exceeding that SLA scenario. So that's all, you know, you can choose that on a per selection basis, which is pretty cool. In addition to that, you know, there's also, you know, reporting. So there's just a multitude of reports you can run on just about anything. You can export those to a PDF. You can export them to a CSV file. So, you know, if you want to give an individual user or manager or office manager, for example, a report, you can certainly export that at any time. And then the Data Explorer basically gives you access into anything into the massive database of things. So if you don't like our pre-canned report on something, you can kind of build your own report based on anything in the database, and even build a customized dashboard of reporting. So, you know, you can make that as custom as you wish. So very cool engine. So this is just the mobile app. So my point here is, in the cloud, you can do basically, you know, anything you can do from the full client, you can do on your mobile phone. So you can monitor all your devices, you know, add switches and access points, you know, add new Wi-Fi networks. You can monitor clients and devices. So pretty much anything you can do, you know, in your office from a full client, you could do, you know, out on your boat in the middle of the lake, right? So, you know, if you're on vacation and someone says, hey, I need to bring up a new Wi-Fi network because the auditors just walked in the door, you know, pick up your phone, 60 seconds later, that new Wi-Fi network is online and ready to roll. So, you know, really as easy as that. It's a pretty full-featured mobile app. Okay, and lastly, so if you want to get your hands on Ruckus Cloud and give it a 60-day trial, we will actually send you a Ruckus access point for free, which you can keep after the trial. However, I mean, it's not our bleeding edge 802.11ax access point. It's going to be kind of a lower end 802.11ac, but you might be surprised. Our low end APs are, you know, sometimes better than our competitors' high end. So contact your Verteks rep, and they will give you a URL to sign up for this 60-day cloud trial. So you use their custom URL. Don't just, you know, Google it and
we'll make sure to get the right thing, and we'll also, you know, get it set up for you. And you can email anybody here in Verteks. We'll also follow up, of course, with all the registrants and attendees with that personalized URL, so they get the right access point and the right promo. And we'll make sure that you get the right cloud Wi-Fi trial, and you also get some tech support. You won't need much, as you saw with what Terry just demoed. It's pretty straightforward to get a Wi-Fi network added, get it set up. However, the first time you do anything, it always takes longer. And I set one of these up in my house. I'm proud to say I'm using Ruckus Wi-Fi Cloud in my home. I love it. One of the things we didn't go over on here, but I'm super excited about, is the using this mobile tools. So it's just very cool, easy to use. I kind of geek out on those things myself, but I like using the mobile tools. and it was not that hard to set up. Although, again, the first time I did it, it took me a little bit longer. Now, if I did a second one, it'd be super quick. So get an email to me, and we'll follow up with you with that personalized URL so you can get that free trial. And the AP that you get, it's free on cloud for 60 days. At the end of that 60 days, you can get a cloud subscription and keep it on cloud. If you prefer not to do that, you could go to Ruckus Unleashed, change the BIOS on it, and then just manage it from the Unleashed, which is a direct kind of built-in web interface management. So it's not a brick. You could still use it.
and I didn't mention that, even though we were talking about 802.11ax, our controllers will manage AX and AC in previous generations. So
right.
You're not, if you get an AC access point, you can mix and match that with AX anywhere you like. So you're not, it's not a forklift upgrade to go from AC to AX or backward. Right. So
a good point. I mean, if you've got an area of your building, like a gathering area or a boardroom or a conference room, or, if you're in government and you've got like a city council room or county commission room or whatever, if it's a school and you got an area where kids are doing testing and you're worried about density in that one area, you could just do Wi-Fi 6 there, right? And then keep Wi-Fi 5 in some other places and do more of a gradual replacement as budget allows. I know that as we look into the future, we could run into some challenges with budgets just due to lack of revenue from COVID. I know a lot of our government clients are affected. A lot of private businesses are majorly impacted with their revenues. So it's nice to have that approach where you don't have to do a forklift. So I'm glad you mentioned that, Terry. Thank you.
Right, and this is not bleeding edge. So we've been shipping 802.11ax for over a year and a half. So
right.
So you are not a bleeding edge adopter, right? We've been through the trials and tribulations of a new evolution of technology, and so it is rock solid. There is 4 or 5 different shipping models of AX access points from us and other vendors, and so it is now a tried and true technology. So don't worry about having to go through the bumps and lumps with us. And the other thing that I didn't mention, which is also important, is if you use a lot of 2.4 gigahertz in your environment, AX, all the benefits that apply to AX apply to 5 gigahertz and 2.4 gigahertz. So in 802.11ac, it only improved 5 gigahertz performance. In AX, it improves 2.4 and 5. So even if you're a 2.4 gigahertz user on hand scanners in a warehouse or something like that, you will see those same massive improvements in performance. So it applies to pretty much anyone.
That's a great point, actually, and I think a great way to conclude this webinar on that high note, which is all these advancements are things that I think all of us are going to benefit from. They're out in the market. It's a tried and true now. Ruckus has been leading with it for a while. And I love the idea that you don't have to forklift it. I mean, that's another great example of how Ruckus is helping people save money and not have to do these kind of rip and replace upgrades, which are maybe harder to afford in the future for sure because of just budget challenges due to the pandemic. So glad everybody joined us. Thanks for attending. We're going to post a copy of this on our YouTube channel, send it to everybody. We're also going to follow up with a link with that URL so you could request a free cloud Wi-Fi trial like we discussed, or you could email me or anybody else on the Vertex team. We're glad to get it for you. Thanks to our guest speaker, Terry Henry, for presenting on this content and giving all this technical information and really giving us some training on the benefits of Wi-Fi 6 and how these new technologies can help us all in the future. Anything in closing, Terry?
No, that's great. Just, we're looking forward to really getting, everybody having a Wi-Fi 6 device in their hands and truly reaping the benefits of many years of hard work from a lot of us. So.
Great. Well, thank you very much, everybody, for attending. That concludes the content. We'll stick around for another second and monitor the chat and questions window. Have a great day, and we'll see you soon.